So on Tuesday, we looked into steel composite bridge. Today, we'll be looking into prestressed concrete bridges. Also going over the varying geometry of the bridges, varied sections as per the standard or customized, straight, skewed, or curved layout of the girder, how to manage both the superstructure and substructure, and construction sequencing, considering if it's a segmental, and also distinguishing the precast or cast in place, pre-tension and post-tension. Then the moving load application will be discussed also at the end. So as you can see, Midas Civil provides you AASHTO and state standard sections. This is the main dialog box that you will be seeing for the section. So as you can see from box, multi-cell, single cell, and IT or half shape, and also as per different standard, the program already provides you. We are also in the middle of implementing the state DOT PSC beam sections, and also varying taper sections can be handled in Midas Civil. This is a tool called Section Property Calculator. In this tool, you could draw your customized sections. This is one example. From composite to non-composite or beam, box, any type can be handled in Civil using the section database and the Section Property Calculator tool. So straight, skewed, or curved, and also you can see different type of girders as an example with these three pictures. How the main girder, beam, cross frame can be all considered together with the substructure as well. For considerations of the deck pouring sequence, time-dependent concrete property, and stressing, using the functions in Civil such as construction stage definition, time-dependent concrete property, and tendon definition. As you can see, starting from the substructure erection to the beam installation, then deck pouring, and also tensioning, either post or pre-tensioning, anything can be handled. Time-dependent material property will allow you to reflect the type of the beam or the cast, and also utilizing a function called composite section for construction stage, you'll be able to distinguish the non-composite and composite state, or consider the deck pouring this way too. So you can distinguish the part 1 girder, part 2 the deck, and also define the age. If it's a cast, if it was a pre-casted beam, you can increase the age in order to reflect that too. First, stressing, you can over here, starting from the defining the tendon property, then moving on to the stress and profile definition. You could handle any type of stressing in Civil. As you can see, different type of tensioning and stressing, and how the checking is done, grouting, and also different ways of handling the profile, whether it is straight, curved, or you can also have the elements as the axis reference. As a bonus, there's a tool called Tendon Profile DXF Import for the tendons. You can also utilize this one. Simply select the tendon profile that you have in CAD format and import the tendons too. I'm going to now start the demonstrations. Before that, this is the outline of the demo today. For each portion, I'll be discussing about each topic briefly in the PowerPoint, then go to the program and show you in the actual the interface. So first, we'll go over the graphic user interface, then how the geometry is handled, then the bridge analysis and design. So the user interface of Civil mainly, so starting from this main menu, this is the ribbon menu system. So it's it's a very similar type as your Microsoft Word package. It's the most, it's the latest graphic user interface that you can see. And also with the user intuitive icons, you can find all of the menus that you need for the modeling and analysis and design, any part of the bridge projects. I'll be actively using this main menu today, so it seems very familiar to you by the end. This is another tool, another part of it called tree menu. Utilizing this, you can easily modify any input or see the input in the model view and modify them on the spot. Through the message window, the program communicates with the user. It's not a black box. It will let you know either the warning message, error message, or analysis message. It will let you know what just happened. This is for the. You can also utilize the shortcut icons for the different perspective view. And drag and drop feature, using this tree menu, you can easily change the model like this. So I simply dragged and dropped a multi-cell section. So from just a plain rectangle section to a multi-cell section, the property has changed by dragging and drop from the tree menu. So this is the model that I'll be going over today. It's a simple two-span PSC I-beam bridge. It runs 320 feet long, each span running 160 feet each. So as you can see, it's a 3D view. I have 5 lines of girder and 1 substructure. And you can see this ribbon menu over here, starting from view and going toward the result and the post-processing. You can follow just the flow of the menu from left to right. And this is a tree menu that I mentioned before. You can always check what are the inputs that you defined so far at any point of the modeling and get to the user interface of a specific input right off this the tree menu, and also modify them, change or delete, and also modify the actual model utilizing this workstream menu. And this is the message window. You see I ran the analysis for the completed model already, and it's showing you the analysis message through the message window here. So now we are going to go over how geometry is handled in Civil. For property, everything about the properties, material sections, you can find everything under this properties main menu. So for the material, we can define the standard basic material, then more advanced time-dependent material, plastic material. Section properties for the basic sections. Then also for stress, point, or reinforcement, you can go the section manager. So these two over here, material properties and section properties, we'll go over them in details today. And these are the two main interface for the material and section properties. Now I'm going to open a blank program. So when you first open your program, you're going to see a blank screen like this. After configuring your program through this register protection license, using your ID, password, and protection key ID, nope. Okay. You can open a new file or a file that you have already. And when you open it, you're going to first define your units. Over here under Tools and Unit System, so at the very end, you're going to see a menu called Tools. Here you can find all different types of tools that helps you to accelerate your modeling process. One of them is unit setting. It's already set as feet. I'm going to change it to kits, then BTU, and I like to set it as my default system. Okay, and also in the middle of any part of the modeling, if you need to change your unit, here at the bottom, I hope you can see my mouse at the bottom over here. This is a statues menu bar here. You're going to see different types of statues of the program, and one of it is unit. At any point of the modeling, you can switch the unit system very flexibly over here. So now, when you first start, what I like to do is go to the properties portion. The reason why I go to the properties before going to node element or structure is because, for example, when you create an element, over here I came to node element and create. When I create it, I can also define the material and section at the same time. So right now I don't have anything defined, but if I have something, as I lay out my elements and node, I can define the material and section properties. So it's much more convenient. I don't have to come back later and apply the properties again later on. So for that reason, what I first do when I work on Minus Civil is go to the properties over here. So starting from the material, as you click on this material properties menu, this box comes up. You can easily go to the section properties portion by switching the tab. And when you click on add, you're going to see this main material data box. We also saw this in the PowerPoint. So this is the main dialog box for the materials. You can select the type of the design, steel, concrete, or steel reinforced concrete for defining both the steel and concrete together. And user defined if you have any other type of materials. So I'm going to define concrete. So, and over here when you select the concrete, the data for concrete is activated. You can either select the code so that the property values under concrete is updated automatically. Also, if you have any reason to modify the material data for your project, for example, I need a weightless concrete for the dummy transverse beams. You can change your standard to none and activate the input cells over here. So I'm going to 0 everything except the modulus of elasticity so that only stiffness is used from this material. Okay. I'm defining it as grade C4000, density equals to 0. So after defining the material, you can go to, or the order doesn't matter, you can also define your section. When you click on add, you're going to see the main dialog box for the section data too. So over here, you're going to see different types of sections over here. Starting from the database or user-defined. So basically, the very basic sections, angle, channel, eye, pipe, box, solid, rectangle, can be all found under DB. And here you can define your section. You can either select the database or user define it. So when you define your section, the difference between the OK and apply in any dialog box in Minus Civil, any of the OK and apply that you see, the difference is when you click on apply, the window will stay with you so you can continue working on some additional components. When you click on OK, the program will take it as you're done working on this dialog box, So it's going to close the box. So value over here is to define different sections based on the values. If you already have the properties, you can utilize this too. Special types, steel reinforced concrete, or combined angles or eyes can be also defined. And PSC. So PSC is, I'm going to define PSC section for my main girders. So over here, you can see when you pull down on the types, you can see different type of PSC sections Midas Civil provides you. Starting from 1, 2 cells, 3 cells, or multiple N cells in different types, I, T, and half, all of them you can find the type. And also for I section, we currently provide the section database for as2 type, modified, and Caltran. And we are in the middle of implementing the state DOT standards for the PSC sections. So today I'm going to use the as2 type 6 beam. So I'm going to apply this. Over here, you have multiple options when you model your concrete bridges. One is to define your beam and girder separately. So you can define your, you can first model your beam and then apply the concrete as a beam element or plate element. Another option that Midas Civil provides you that allows you to do everything at once is utilizing the section called composite type. So over here under composite, you're going to see different type of composite sections. For steel, steel box, steel eye, you see the view changes over here, steel top, and composite eye. So basically the same thing as we saw under the PSC, but then we can combine the concrete and girder. It doesn't mean that in Midas Civil the concrete and girder has to be like just stuck with each other together. We can of course distinguish the composite non-composite state or the deck pouring differently from the beam installation. Composite T, composite PSC in case you have a customized section defined in the section property calculator tool. Composite general, you can import everything just based on the pure values. So I already defined my as2 type 6 beam. So here what I'm going to do is I'm going to create a composite section that that combines the beam and concrete. A hint for this is that we already defined the beam by selecting the database. So do we have to do it again then over here? No. Midas Civil provides you import feed function for many part of the program. DXF import for the outline of the structure or the tendon profile, and also over here from those major things to the little things, just importing the beam section from what I have defined already. I don't have to define the beam one more time. I can simply click on import and select the PSC section that I defined already. So I'm gonna just import this one. We see this was blank initially. Now we have the beam imported from what I defined already. So we only need to define the deck on top of the just importing the beam here. Slab width, it's 10 feet wide. So before I for a second mistaken this as an inch and I put 9 feet. So over here the drawing looks abnormal, so I can easily notice if I'm doing anything wrong. And fix. And over here you can select the different data for the girder and the slab so that the program can consider the different stiffness. for the deck and the girder. So ASTM for the slab, 4,000 for the girder. 5,000 is what I have for the model today. So as I define them, as I select the material database, the modular ratio value has been updated, and so are the rest of the ratio values. So that's how you can define the section and material in Midas Civil. And as I mentioned before, when you go to workstream menu, you're going to see everything that you defined, all the inputs that you made so far at any point of the modeling. You're going to see everything uploaded over here under the Works tab, Tree menu. And you can always go to the Tree menu over here, go to the Material Property. Another benefit about this Tree menu is that this one provides you a shortcut to each input system. So over here, I can either go to just the tables, straightforward, or you can go to the main menu over here, and there's a table icon, table menu. You can get to the tables for different section and material properties under this table icon, or you can always right-click over here and go to table, and also you can add a section. You can also modify what you have already, utilizing the workstream menu. Okay. So now the structure. How do we define the structure? So structure can be defined utilizing the structure and node and element tab. So basically under the structure, you can define the basic structure type. Is it 3D? Are you trying to convert the mesh to the load? Those things. And also over here, you can see it zoomed out. You can see all different types of wizard, different type of the segmental construction method wizard. So when you use one of this wizard, the program can automatically create the construction stages or sequences, and also cable, suspension, from those complex, and also this simple base structures, composite bridge, PSC bridge, grillage model, transverse model. You can find all really helpful wizards in this structure tab. Couple examples of the wizard. So base structure, I'm gonna actually show a sample with the beam. And here you can see different type of segmental bridge wizard and grillage model wizard for the multi-cell box girder bridge. Also, another way to define your structure is utilizing node and element main menu. So structure, basically it has all different menus for the structure, profile, property, or the type, and wizard. And under the node and element, you're going to find all the menus that you need for working with the node and elements. So starting from creating, translating meaning copy and move in Midas Civil, dividing it if there's one, if you need two on the same spot, merging it if it's the other way around, delete, rotate, project, mirror, scale. It's very straightforward and literal. And for the element 2, creating, then translate, meaning copy or move. They actually, copy move function share the same interface structure. So it's put under translate. And extruding from the beam to the plate or node to the beam, dividing. If you modeled two giant girders, and if you like to divide them, to segment them, you can utilize this too. So I'll be using a lot of the node and element functions for creating the structure layout. Couple sample interface. It's mainly going to look like this for the node and element portion. So creating node. So you can input the coordinates. You can either click in the model or manually input over here. And also at the same time as you create your node, if you would like to copy them and generate multiples of them, you can utilize this copy option at the bottom too. And also translate for the element equal distance or by unequal distance. It doesn't always have to be uniform. the program can handle copying or moving it at unequal distance multiple times. And extruding, as I mentioned, node to line element, or as you select a different type, line to plane element, and stuff like that. So this is the model, the same model for our demo project, with all the property that I need for this modeling defined already. So as I mentioned before, type 6 composite is there too, and the rest of them, just the basic pier cap, solid rectangle sections or round sections, and the diaphragm transverse beams are defined already too. So over here, we are going to create our superstructure. So for the structure, here we have base structures. I'm going to show you one example with the beam wizard. The span runs 160 feet each. So I'm going to say to add 160 feet. And add, you can see the layout created over here in the view window. And as I mentioned in the very beginning, I can select the material and section based on what I have already. I have my sections and material ready in the before this, so I can actually, when I press this, OK, please pay attention to the model view right here, model view. You see the property of the section and material are applied automatically as I define the beam. So this is the one main girder line. Under the node, utilizing the node element functions now, I would like to create multiple lines. I have total 5 lines of the beam. So I'm going to translate elements over here, element, translate. As I mentioned before, translate meaning copy or move. They share the interface, so you can simply select which mode of translate you're in. I would like to copy these. The deck is total 10 feet wide. So equal distance of total 10. How many times? 4 times. So you can see I generated 2, 3, 4, 5 lines based on the first one. If you have longer overhang for the exterior beams, no problem. You can always utilize our section property calculator tool to customize the unbalanced asymmetric deck dimension or anything. Then over here, now I'm going to apply the diaphragms here. I'm going to create elements, create. And here we can select the different type of elements, truss, cable, compression, or solid. I have general beam / tapered beam. Selecting the grade C4000, which is the material for the whole substructure concrete materials. I'm selecting the diaphragm here as the section. Then I can click on nodal connectivity. This turns into green when you click on the window. Whenever these type of the cells turn into green color, it means in Midas Civil, it means that you can actually click right on the model view and provide the input values. So I'm going to turn off the hidden view. So basically view, render view, I can utilize this hidden option to see the section property in 3-dimensional. So I can check in the middle of modeling if anything has gone wrong. I can check very easily with the render view. So here, as I mentioned before, when you click on the nodal connectivity, the cursor has changed now to like a cross. So here I can simply select the nodes and define my beam. With the 3D view on, do you see this diaphragm defined? Okay. Going to do the same for the middle and the end. And now our girder is total 320 feet long, but right now I only have 2 elements for each span. That is not really the optimum condition for the finite element analysis, since the program calculates the value at the end of each element at each node. So if I only have 1 element per a longer length, it means that the accuracy goes down. So in order to properly reflect the length and also the finite element analysis, I like to divide it under the node element menu over here. I'm going to divide these main girders in the longitudinal direction by equal distance. You can also divide it by unequal distance or parallel bracing, or you can divide it by the node. This time I'm going to divide it by equal distance 40 times. So you can see the node has been created over here between amongst the girder beam. It doesn't only mean that only the nodes are created, also the beams are now segmented. And if you need to check the distance between the 2 nodes, you can always go to query, and there's a function called query nodes, or you can open this up simply by pressing F4 key. So the program actually provides you a shortcut key for a lot of the menus. Whenever you put your cursor over one of these shortcut icons, the program will show you the shortcut on the keyboard. So utilizing this query dialog, you can check between 2 nodes now. It's 4 feet apart. So from 160 feet long beam, I segmented them by 40 times so that each beam runs 4 feet. Also, you can go to element, click on it, and then the message window right over here. So as I mentioned before, message window is where the program communicates with you, tell you the information, error warning message. And over here, you can see the element 14 ID, what type, and the material, property ID, and the rest of the information like nodal conductivity or even the total weight based on the section and material that you defined. So now, right now I have the main girder and the diaphragms. We are done with the superstructure except one thing. As you can see, we have composite sections. So when you look at the 3D view, it actually looks like it's fully connected. The decks are connected and the diaphragms connecting it. Lowever, when we look at the frame view, we can see the deck is actually a section property represented in the 3D view. So when we turn on the frames only, we only see the elements running in the longitudinal direction. In order to provide equal stiffness in the transverse direction, I need to model the dummy transverse beams. So that also I can do using this node element over here. I can again create elements. Over here, I can select the grade C4000, which is the concrete deck material, but without the weight density. Since this will be a dummy transverse beam, only the stiffness in the transverse beam will be counted without this weight or anything else. Since we are going to utilize this composite section deck for the rest of the longitudinal stiffness or weight or anything. So for the transverse, we only need just the stiffness, so only the modulus of elasticity is defined for this type of material. Whenever you need to check, you can, you're going to see this button many times in Midas Civil. This one basically means that in the middle of any part of the modeling, you can always go to, let's say you need another material type, or you need to modify something. You forgot to do that when you first worked on the material. Then you can always click on this without closing this window. you can always just click on this dot 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 and directly go to the material properties dialog box. And as you select them, you can always modify freely too. So whenever you see dot dot dots, it means that if you need different type of input for the specific category, you can always define it right off the spot. That's what this one is for. So I'm going to define transverse beams. One samples for each span. And then I'm going to copy them so they can be installed throughout the whole girders. And over here we have different type of selection tools. Select single. So basically selecting the node and element one by one. Select rectangle. If you like to do this, that's the window. Polygon, if you need to select elements in an irregular selection area, you can do that too. And the gray ones are basically for unselect. So I like to select the transverse beams that I just created. I'm going to go to Tools, go to Customize, open up another tree menu. Over here, I can open the second tree menu, so I can have two panels of the work tree. Here, I'm going to double click on Section. So this is another benefits of the tree menu. Whenever you double click on any of the input in the model view, the elements that this specific input is applied to is highlighted. So we can see these are the transverse beams. Those are the ones that I need to copy. So I'm going to double click them to select, go to node and element, go to translate by equal distance of, again, this is green color, so I can select the nodes in the model view to update the value automatically. So 4 feet, how many times? 38 times, since I have 40 elements. So basically the superstructure is, I created everything for the superstructure. If your PSC beam section varies throughout the span or at the negative moment section, you can also handle that using tapered section type. I'm going to go over taper section when I go over the substructure. Before moving on to the substructure, I like to go over the boundary part of the program so that we can work on the boundary condition for the substructure too. So boundary. Basically, under the boundary main menu, you're going to see all of the boundary functions too. Same way as node element and properties. Here we have the boundary. So support, the basic support where you define the fixity in the 6 degrees of freedom to spring or integral or any other type of needs. Here we have link elements, rigid or elastic, and the rest of them. We also have beam and release, which we are going to use later in the model. These are the two interface that we'll be going over today, and also the beam and release. So basically define the fixity in the 6 degree of freedom, and also under the elastic link, 4 different type of elastic link, either general where you can define the stiffness value in the 6 degrees of freedom manually, or you can also select the rigid type so that the program can calculate the value for you. So that's about the boundary in Mired Civil. Back to our model over here. We already defined the substructure. And here we can now go to node element again to define the substructure and also the boundary that I mentioned just before. So, before moving on, I would like to define groups. So groups are basically for composing the construction stages. I'll explain the use of them further as we move on. For now, here under the group, I'm going to create different load groups. So basically, as you go to Group tab, there's Group tab for the load, tendon, boundary, and structure. I'm going to define the groups for structure, boundary, and load group. For the structure, girders, here, diaphragm. Boundary also. So when you click on new ... it's going to open this box for you. Name, support. You can see them updated in the tree menu too. Bearing. Temporary release. Then under the load group, today I'm going to define static load, pre-stressing loads, construction stage load, and moving load. So I'm going to give different groups. Self-weight. Static load, I have self-weight and wet concrete and barrier. Then pre-stressing, 1 and 2. Again, I'll explain about how these groups are used as we move on to the construction stage. So right now, I'm going to create the substructure. So when I double click on diaphragm, I see that this middle portion is highlighted too. This is where I'm going to actively work on for the substructure. So I'm going to activate the diaphragm elements. So over here I have the ends. I'm going to first apply supports at the ends of the exterior ends of the span. So under the boundary here, as I mentioned before, we have define supports. This is the main menu for just defining the general support. You can also define in the table, or you can define utilizing this interface, whichever way that is more comfortable for you. It is up to you. And also you can define using the text file too. Right now I'm going to use this one. So the middle one will be fixed about all deflections in XYZ. And here, did you notice this little guy just popped up? It's the symbol for the support. So I just applied a support and fixed it in all directions of the deflection. So basically, starting from this north direction, going clockwise, this each triangle of the hexagon, it represents the degree of freedom. For starting from this portion over here, going clockwise, dx, dy, dz, rx, ry, rz. So you can actually see what type of support you applied in the middle of modeling 2. And I'm going to apply just to prevent the vertical direction for the other end. Okay, so now I'm going to work on the middle portion. And this icon over here is to control the view. So you can actually have the ISO view at different angles. Plan view, cross-section view, or side view, whichever view you need, you can always get that over here, utilizing this guy over here. I'm going to activate the middle portion so we can concentrate on modeling here. So basically, for the ones who are new to Midas Civil, I activated this portion using a feature called Active here. So Activate basically is to activate part of the structure, so we can focus on one part without getting confused with the other nodes or elements. So since I'm going to work on the pier over here, I activated the middle diaphragm. So first, I would like to copy the node so that I can apply the peer cap. I go to node and element again, and here I have create nodes. Actually, translate. So translating meaning copy or move again. So this time I'm going to select all of the nodes since peer will be running throughout the bottom. So I'm going to click on select all button, shortcut over here. And then I'm going to define the distance. It needs to be translated by negative 4.5 feet by 1 time. The reason why I apply this at negative 4.5 feet is because, let me activate all and show you. Here, do you see the girder is about 4.5 feet long from the centroid. For that reason, I copied the node so that we can actually apply the peer cap over here and the rest of the structure. Okay, so here now I'm going to apply the peer cap. Came to create element. Going down. Again, grade C4000, the material for all my substructures. Then peer cap. And peer cap actually is a taper type section. So taper type section, I'm going to show you in the dialog box. You can see under the taper tab, I have 2 sections defined. Each sections are for I end or J end. So basically, if you have a varying cross section for the girder, beam, or for the peer cap, anything, you can handle that utilizing this section data. So under the taper tab, there's basically from the very basic angle, solid rectangle, to the complicated sections too. The box, multi-cell, single cell, or PSC sections, or composite sections. So the taper type is limitless. Basically anything you want, you can define tapered, flared, anything. You can vary different portions of the section. If you want just the web, you can vary just the web. If you need the web and the deck varying at the same time, you can do that too. You can also differentiate the varying function. Linear, polynomial, cubic, you can define them too. Over here for this type, the y-axis variation is linear. So is the z-axis variation. And we have parabolic, cubic, different types. So that's the peer cap section. I'm going to connect like this. But right now it looks really odd, right? Because the section is applied to each element. The I node and J node are applied for each end of the element. But this is not really what we need. So how do we handle this? In Midas, under the properties, there's a function called taper group. So anything about section, you can come to properties and section over here. Let's say, like, if you are a little bit lost, like where to go, just think about where the input or the function that you need belongs to, and then you'll be able to easily spot it under the main menu that you expected. So for taper group, since this is about the section property, I came to properties, section, then taper group. So anything about section you can find over here. So what this taper group does is that basically if you have varying cross section and you have segments of the elements, then you can actually group them so that, as you can see in this little picture over here, the I and J node is applied to a group of the elements. I'm going to define one to show you, and also that's what we need for the peer cap. So I selected these 2 elements. I'm going to turn on I'm going to display element numbers. Over here, we have an icon, and also you can choose to display this under the display menu here too. And also activate that I used before are also all found under view. So basically, since they are about the view in the model, you can find them under the view main menu too. So basically, I'm going to define group 1 for elements 736 and 737. Here I'm going to edit. So what just happened as I added a group to this taper group function, the taper section for these two elements smoothed out. So the I and J and sections are applied to this one group. I'm going to do the same for the other ends too. And as I mentioned before, for any part of the structure, is it the main beam, main girder, or is it just the deck, or just a part of a flange, or a web thickness? Any little part to the major part of the structure can be varied utilizing this taper section and taper group. Then we have the pier cap left. I'm going to go to node and element again and create elements. Zooming out. Actually, we need additional nodes for the pier cap. The pier. Sorry. So I'm going to translate the node. I'm going to translate this node over here in the middle. I'm going to translate a -5 feet, which is about the distance, which is the thickness of the pier cap. Going to do that 8 times. Apply. So we see the nodes are translated in Z direction so that we can define the pier, the column element. Come to create elements again. So I hope you are very familiar with the how to work with the node element portion. We used it very many times today. Under the pier, I'm going to define the nodal connectivity. So we have the pier now. Okay. So we went over the boundary too before coming back to the demonstrations. Under the boundary, I'm going to define the rest of the boundaries. We only have the support defined for the ends of the spans. This time I'm going to define fixed support for the bottom of the column. And also I need the bearing for here. When I activate it, I have the girder applied to the top nodes over here. But there's no, okay, let me clear the view for a second. I'm going to activate this portion so we can pay attention to this. So over here, do you see that we have nodes for the beam, the girder, and the composite? And the pier cap over here, and pier over here. But then, in the frame view, those are just frames in the longitudinal, transverse, and vertical direction. In order to provide the bearing and the stiffness of the web of the beam, I'm going to utilize elastic link element over here. So basically, under elastic link, I came to boundary for that. And under the link tab over here, there's elastic link. I'm going to define my boundary as bearing. Select the type of the rigid. So I mentioned this briefly in the PowerPoint. General is to actually, if you have the stiffness values, if you have them, you can input them one by one, or you can select the type rigid so that the program calculates it for you. You can also check the stiffness value for this type of automatic link. At the end of the, after running the analysis, you can review under the result tab, tables. So here I'm going to select two nodes over here for the, between the pier cap and the pier. And also I need it for this girder portion. So I'm going to apply the link this way, but then there's also a function called copy for generating the link like this. So as I apply to this one, I would like to have it copied in the Y direction 4 times so that I don't have to repeat it. So I'm going to do over here, select the copy by distance 4 times at 10 feet. Oops. Okay. Let me check the distance between the two. Yes, 10 feet. Oh, Y direction. Okay, so I kept getting the error message saying that the program is unable to find the node at the location copied. The reason is because I try to copy in the X direction. I need to copy them in the longitudinal direction. I need in the transverse direction, but then it was originally on the X axis. So for that reason, the program wasn't able to find the copy nodes. This time in the Y direction 4 times. So the elements, as I create one, multiple are copied for the rest of the beam lines. So we are basically done defining the structure, the geometry of the program. Of course, curved or skew bridges can be handled very easily too, as I showed in the PowerPoint with the pictures examples. If you would like to get to know how to handle curve or skew geometry, please let me know at the end of the session. I could share more materials, or I could briefly go over that depending on how we manage the time. So coming back to load, I would like to first go over the static loads. So this is the load menu in MyResevol. I hope you noticed over here under the load main tab, the same way from boundary. Now we can move on to the load. Here I have static, temperature, moving load, different type of loads. And as I click one, what's going to happen is this ribbon menu is going to show you different menus for different load types. So for the static loads, over here, the static load case. You can define the static load case first for varying types of the static loads. Then these are the two very frequently used for the static load type. Self-weight, of course, where you can define the ratio to the gravitational acceleration, and also the uniformly distributed element. So we can define our load now, the static loads first. And then I'm going to move on to the construction stage and the moving load portion. Over here, I have a model up to the step that we went through with the substructure, main structure. And here under the load, as I mentioned before, when you click on different type of load, you're going to see the ribbon menu changing or to provide you different functions. One of them, the very basic, just the static load cases. This is very similar to, probably similar in all other programs too. Define the self-weight, dead load, wet concrete. This is a temporary load, construction stage load that I'm going to apply at one specific stage in order to reflect the non-composite state deck pouring. Barrier is a dead load. We're also going to have prestressed loads. 1 and 2 for different tendons. Then I can define the self-weight. This is the same interface I showed in the PowerPoint. Basically, you can define the ratio factor to the gravity, and then based on the section property and material property, the self-weight will be applied automatically. Element load for applying uniformly distributed load, or if you would like to choose different type, the program will show you all different types of element loads. Same goes for the other types of the distribution too. With concrete is about 1 cubic feet, let's say. I'm going to go to works. I'm using the second tree menu because I do not want to close this input dialog box. Here under section, I'm going to select the girder section so that all of the element for the girder is now selected. So here I can apply wet concrete load group, wet concrete load case, apply. You can also turn on the load value under the view and display, or you have shortcuts over here too. Display option. Okay. Coming back, this is how you can define your static loads. Easy and simple, right? So now I'm going to go to the construction stage where we are going to spend a lot of the rest of the time today. Basically, construction stage menus are also found under the Load tab and construction stage load type. Here, starting from Define Construction CS, where you control the activation of the different elements, different load, and different boundary. So here, for example, I have 4 stages. This box shows you a summary of it. And when you click on Add, you're going to see this large box for defining the construction stages. So over here, you can define the duration. If you have multiple steps, let's say you're activating your tendons at different days, within the stage, you can specify your steps too. Let's say you wish to activate your a part of the structure at a different, in the middle of a duration. You can also add steps for that too. Element, basically, remember we defined the structure group and load group and boundary group. Those are for here. So over here under element, boundary, and load tab, under the list, under the group list, these are the names that we defined when we defined the structure group, boundary group, and load group. So that's that's how we utilized grouping for the construction stage. And of course, when we have the beam and the deck defined as the composite section, we can always distinguish the non-composite state utilizing this feature right here. So you can, for different parts, one for the girder and 2 for the concrete, you can select different material property and also different composite stage, meaning when each part are activated, and age over here. So this is very critical for concrete concrete structures or steel composite bridges. So over here, age is to reflect to reflect the compressive strength of the material that you selected. So basically, for the part 1, I have age of 3, meaning the girder as the structural element is activated in the program with the stiffness value that the girder gains at 3 days after 3 days of the pouring. And 11 means, the stiffness of at 11 days. That's how this material property is activated. So basically, age can reflect the duration that false work is kept. If it's a precast, like you can increase the age to a large number so that the stiffness is for sure it's already reached its compressive strength. So now I'm gonna go to the program and show you one by one. There's one part that I skipped before when I went over the material property. I didn't touch up on it since it's more advanced than what I needed to cover in the very beginning. Over here, under properties, we have different time-dependent material properties over here. So basically, in order to reflect the long-term and short-term material property, there are multiple ways that the program can handle, from simple to more complex. So simple ways will be basically here under the section. When you click on your, okay, this is not it. So when you go to your section properties, I'm going to show you an example. When you go to composite over here, you can actually choose the material from database for the girder and the deck. And also there's another option that you can check on. This is a multiple modulus of elasticity to basically reflect the N, 3N, or anything else for creep and shrinkage. So basically this is a simple way to consider your the material property. And another way to consider this is to utilize this creep shrinkage. So basically, when you define your multiple modulus of elasticity, you can each section will have different stiffness value for N and 3N. And when you define, when you actually check on the multiple modulus of elasticity, you're going to see the stiffness updated for different states. Right now, that's not the approach that we are going to take. I'm going to use the time-dependent material database the program provides you. So here, for creep and shrinkage, you can add creep shrinkage. Basically, as per the code that you need, you can provide the input. Okay, I'm going to switch my unit to inches. Let me exit out for a second. As I mentioned before, the status bar over here has the unit section. Here, I can just click on inches and change to a different unit. And all of the input, you don't have to worry about the conversion issue. As you change from feet to inch, every input and output, either in the post-processing or the pre-processing part, whichever part you are in, the values will be all updated as per the unit setting that you have. Characteristics, compressive strength. Here I'm going to say C4000. Notational size of member, I have it calculated already. So this is how I can define my time-dependent material property. And utilizing the age in the construction stage definition, I can activate the material at different day so that the coefficients of creep shrinkage and compressive strength can be reflected and activated with the stiffness value that I need. So basically, you can see the graph. If you need to modify them, you can do so too with the graph. I also need one for the girder material. So I have two creep shrinkage. Then compressive strength. And the same way, you can select the code. And also for creep shrinkage, there's H2 code. And here I'm going to use this portion for the grade C4000. You can draw the graph. So you can see, based on the code, the compressive strength graph. And let's say I need to activate the beam, the girder, with the stiffness of, let's say, 6 days with 3 KSI. Then you can define your age to be age as 6, so that the element, when it's activated, it carries the stiffness at the day of 6. So basically, you can reflect the actual construction, the false work, application, and so on. Going to do the same for girder. So now I apply I'm going to apply this time-dependent property to the different concretes that I have. to the C4000, yes, and also to the dummy concrete, yes. Going to apply the same for the girder, 5 KSI, yes. So now each concrete material has a different time-dependent material property function applied to it. Now I can finally go to the load, and under the construction stage over here, we went over this in the PowerPoint, there's define CS for controlling the global the construction stages. As you click on add, this giant box will come up, and here you can define the name, duration. I'm going to activate my pier, the substructures, and girders. The girder is actually the girders and with the composite section. So right now, when I activate the girder and pier, both the girder and concrete will be activated at the same time. But utilizing this portion, the add modify composite section for construction stage, I'm going to distinguish them over here. So right now we are at define CS here, and after controlling the global construction stage, I can control the composite sections utilizing this function. Okay, so I'm activating the substructure and the girder first. Actually, pier will be activated with the 28 with the age of 28, so that the substructure fully gains its strength when we actually have it play a role in the stage analysis. Or you can it's this age or anything about the constructions. It's purely up to you and how it's actually done. For the girders, I'm going to activate in 7 days. Boundary, support, and bearings. Bearings, this one contains all the links for the bearing portion, and support, the fixities. So I'm activating these two, and the temperature beam and release too. And over here for the load, I'm going to activate the self-weight and wet concrete. Wet concrete actually needs to be activated when the girder is activated. So I'm going to add a stage of, let's say I'm pouring concrete after 20 initial days. So I'm going to, for concrete, I'm going to have the activation day to be 20 days. So we can give some time for the beam to pick up its strength. And barrier is now, it's going to be applied at the end. Pre-stressing 1 will be applied over here. Stage 2, here elements, I already activated pier and girders. So this time, in stage 2, the deck will come in finally. So the transverse beams representing, these are the dummy beams for the concrete deck in order to provide the equal stiffness in the transverse direction. I went over in the very beginning too. So this one I'm going to activate in the second stage with the age of, let's say, 7 days again. Boundary, the temperature release will be deactivated in the second stage. And the load over here, I'm going to activate pre-stressing 2. I didn't go over the pre-stressing loads yet. I'll get to it after working on this portion. As a last stage, stage 3, I'm going to apply the boundary, no, just the load, the barrier load in the last day of the stage. So basically, after waiting for about 30 days, I'm applying the barrier. Right now, I only have barrier, but if you have any other types of additional dead loads, you can apply them in the last stage. The staging can be done. It is purely up to you. It's really easily customizable, and also it's very flexible. The number of the stage you can define is limitless. So if, let's say, if you're activating spans or per segment, you can also handle it that way too. So right now we just have construction stage like this. I'm going to turn on view, hidden view, so we can see it realistically. As I mentioned before, the deck is activated at the same time, and we need to handle that using the composite section for construction stage. But right now, I would like to give you an overview of the construction stage we have. And as you can see in the workstream menu, you can see different items are activated. Under the stage 1, I had the beam and release and only the self-weight and the wet concrete weight. But in the second stage, as I changed my stage, I have different, the beam and release is now gone, and wet concrete actually needs to be deactivated. I'll fix that soon. Stage 3 with the barrier load come in. Over here, the load come in, so we can see it too. Going back to base stage, let me quickly fix the load portion. I would like to deactivate the wet concrete where the actual concrete is activated. Okay. So this time under load construction stage type, there's composite section for CS. Okay. Here, this is where I mentioned that the distinguishing the girder and the concrete can be handled. Applying different material for the deck and the concrete portion. We can differentiate the activation stage 2, stage 1 for the girder, stage 2 for the concrete, and age. Both will be activated at age of 7, let's say. So now what happens is that from 1 to the deck activates later on. So that's how you can manage your construction stage. Now I'm going to cover the pre-stressing. Basically, pre-stressing menu can be also found under load, temperature, pre-stress. And these are the menus for the pre-stress loads. And these are the 3 main steps: property, profile, tendon. The stress. And the rest of them, if you just want to apply the pre-stress as a beam load or tension, you can do so too, utilizing the sub-menus. These main menus are to define the tendon. So defining property, you can define different types. For the profile, you can define straight, curve, or using the element layout. And also stress value, you can apply jacking at begin or end only, or at both. And also define the stress by force and stress, and grouting can be defined too, very detailed. So over here, we already have construction stage defined. Actually not this model. Okay. So here I'm going to go over how we define the tendons. Under load over here and temperature / pre-stress, we're going to see the menus over here, same ones as we saw in the PowerPoint. So whenever you need anything about the tendon, always come to the load over here, temperature, pre-stress, then the menus are ready. And good thing about Midas Civil is the most frequently used menus or the main core menus that you need for each function or defining each different input type, those are actually bigger. It's actually bigger so that you can easily spot them. So it's very intuitive. So the main core ones that you will really need. If you're not familiar with the program, if you do not know what exactly to get to first, just pay attention to how our menus laid out. Obviously the property is the initial step, so it's on the left, so you can go from left to right. So basically for modeling, you can follow the left to right flow through the whole ribbon menu. Then you'll be able to actually get a lot of the program. So here I have the tendon defined already. with the post-tension type, here I can select the total tendon area based on the number of the strands and the diameter. And here you can define different relaxation coefficient or other the loss-related inputs. And over here I have tendon profile. I'm actually, okay, I'm going to open what I have. Here I have profile defined based on the element reference axis. So basically, there's multiple way to input your profile coordinate. Basically, you can utilize X, Y, Z coordinate. You can have this reference axis is really convenient. If you just want to define straight axis, you can use this. If it's a curved, you can just define the curve with the distance. This is just the distance, the circumference of the curve. And here, utilizing the radius and insertion point and the angle, you can define the curvature too. An element, I actually find element very convenient and easy for me to work with. Basically, with the element portion, I can lay out the tendon based on the element that I have already. So if your bridge is curved, if you have the main girders in the curved layout, you have two options, either curve or element, and define the coordinate, the distance from the insertion point based on the element or the coordinate. And also not to forget, we also have a feature where you can import your DXF. So that's another merit about working on the prestressed bridge in Midas Civil. So basically, this one is for the bottom portion of the beam. So I named it as bottom tendon. This one's just a straight tendon. So you can see it with the name and the profile layout over here. And another really nice feature over here is to define typical tendons. So let's say you're working on a preliminary design step. So you do not wish to model the tendon multiple times. Then there's no need to go through all the burdens of defining the same one multiple times. Just define them on the same spot, or like differentiate the location a little bit. You don't have to go further for the preliminary stage. You can actually use this typical tendon option. When you click on it, this number of tendon is activated. So you can increase. Let's say you have about 8 strands at the bottom portion of the PSC beam, then you can simply click on that and increase the number. So when you review the loss or stress values, you can see the effect of the 8 tendons on the same position. And also, I generated the rest of them, the tendon bottom, copy 1 to 3. I generated them utilizing the copy and move feature. So copy and move, I'm going to show you how I do it. So I'm going to, let's say I wish to copy this bottom tendon to the other girders. Then I can select this and click on copy move. And here, copy, I wish to assign it to the other elements. You can simply add. And when you close, after clicking OK, it's going to generate the copies of the original ones, but apply to the newly selected elements. Again, I wish to do that for the rest of them. I'm going to test this one and the second line as of now. And if it's a curved bridge or a skewed bridge, let's say the length of the beam varies, then what you can do is you can actually have the program automatically adjust the tendon length according to the element that the newly assigned element sets. Okay. So that's how you work with this copy move tendon profile. And as I mentioned before, you can export it to DXF, and also you can import using import over here using the tendon profile generator. We saw this interface in the PowerPoint too. You can basically import the tendon and define them here too. If you just want to apply the prestressed as beam loads, you can do that too. So that's about the prestressing in miter civil. The last portion, we have moving load over here. So basically, under load, moving load, we see the moving load menus. The program provides you different database, different moving load code, as to LRFD, as to standard, the Caltran, and also we are in the middle of implementing the local state legal load database. So again, this is the same for the moving load. As I mentioned in the beginning, you can pay attention to the large icons, the large menus. Those are probably the core ones that you need for completing each step. If you need to get more advanced or provide detailed input, you can pay attention to the sub-menus. But mainly, it's about these large icons are what you need. So here, traffic line lane, if you have a frame element modeling, you can do the line element. If you have plate finite element modeling, or you have the deck as a plate element, you can utilize the surface lane too. And here, the different vehicle load, you can select the standard, and also as per the standard, the program provides you the vehicle load database. Not to forget, there's rail loading and also the state legal load coming up soon in January. Rail we have already. The state legal rail rating loads will be there from the December release. And also user-defined vehicle. Permit truck, train truck, or truck/lane, any type of customized the vehicle lanes, the loads can be defined utilizing the user-defined vehicle load function. Here, different types. And here, the last step, the moving load case. Here, you can define the multiple presence vector. You can tie multiple vehicles into the lanes, define the worst case loaded lanes, minimum number of loaded lanes, and so on. So basically after, that's actually the main components. We covered the main components we need for completing the pre-processing part. Now moving on to the bridge analysis. Under the result tab, you can review different type of outputs, starting from the basic result. Here you can create the load combination. There's an auto load combination generation function as per the code and type of the structure that you select. And result over here, reaction force, moving load specific result review features, and seismic, and so on. So basically, this basic, the 6 type results can be reviewed for post-construction stage or for each construction stage. And also you can, here you can select the load case combination, different components that you would like to review. And you can also review in the table. This is reaction beam force table. And also this is for the tendon primary. So tendon, anything, the dead load, live load, can be all viewed with this basic result format, and table over here too, and text output. As you can see, for tendon, about each step in the construction stage, you can review the value this way. Not to forget, you can also review the tendon loss with the graph, like this. Under the result tables, there's tendon portion too. So basically, all the results can be reviewed in the tabular format too. And one of them, tendon, you can review the coordinate, the elongation, arrangement, the loss, approximation, and the stress limit check too. And as per, this is the type of the loss in detail. You can review in miter civil. For the moving load result, over here, as you tap down on the moving load result tab, here you can actually obtain the concurrent forces and reactions utilizing this moving load specific result features. Not to forget, there's also the text output is available for the output, input, or when you wish to give an input, or when you want to see a summary of your input. Anything is also available in the text format. It's Midas Civil is very advanced graphically, but it doesn't mean that we abandoned the text and the conventional format too. You can, whichever way that is better for you, anything will work out. Okay, thank you very much. That concludes my training today. If you have any questions, I actually see some questions on the question panel. I'll have them answered to you at the end of the session. And also, if you have any further question, you can also let myself know. You can email to angelakim@midaseizure.com. Again, angelakim@midaseizure.com. My full name and last name @midaseizure.com. Or you can also let me know through our the marketing steps too. I have a question asked over here. Yes, grillage can be used for the curved girders. The torsion can be also handled. For this one, I'll actually email you more in detail with the email. For time being, as of now, I'll conclude the presentation over here. And Mr. Salim, I'll get back to you with the email. I have your information from the registrations. Yes, I have your questions saved. I'll have them answered, and we can also continue our discussion. Thank you very much, everybody, for your time today. Have a great day. Bye-bye.